doing today? Today we're going to talk about, in this video, direct and inverse variation. You're going to have to follow along in the book because these are word problems, and we're going to read them extremely slowly and then work through how the equation looks. So let's say first, this is 9.2 in your book, and we want to define direct variation. Direct. We use the variable y. Y equals k times x, and k is a constant. Okay, so when we talk about direct variation, we're saying that there's a constant here, whatever that may be. But as this increases times the constant, y increases. It's a direct variation. As one increases, the other increases. As one decreases, the other decreases. Now let's take a look at inverse. The equation for that is y equals k over x. Again, k is the constant, but notice that this time x is in the denominator. So as y increases, x will decrease. They are opposite each other. All right. Now that we've swallowed that, let's take a look at number 2. It says, the pressure P of a column of liquid varies directly as the height h of the liquid. Okay, so we've got P as the pressure. Let's put that down, P of a column of liquid varies directly. Here we are, varies directly. So we have P equals K, varies directly, as the height of the liquid. And that is the equation that you would use for that set of circumstances. Okay, now let's take a look at number 6, as long as we have a little room here. The intensity of illumination E produced by a source of light varies inversely. There's your words there. Varies inversely as the square of the distance d from the light source. So here we are with E equals, and we know it varies inversely, so we want that k on the top. Now, be careful here. The square of the distance d. So we have to take that d and square it. That is the equation for this word problem. Varies inversely. Get the idea? Okay, let's try another one. Let's try number 10. It says P varies inversely as the cube of S. Okay, let's write that equation first. P varies inversely, so that means we have k on the top, as the cube of S. Okay, let's put that down, the cube of S. And P equals 8. And S equals 2. Therefore, we can find out what this constant is. So we have 8 equals k over 2 cubed. So we'll have to inverse this, so we have, or do the algebra, okay, times 2 to the third. 2 to the third is 8, so we have 8 times 8. So 64 is our constant. Now, what does that mean to us? Okay, if we had something else that varied according to this equation, we could simply substitute in the value for P and use the constant that we found, 64, and find out what S is. Let's see how we apply that principle. Okay, we're going to go to number 14. All right, let's just read it first. If P varies inversely with Q, okay, P varies inversely with Q. Inversely, we know, belongs as the denominator. P equals 30 milligrams cubed. When Q equals 10 kilograms per millimeter cubed. Okay, you're going to listen to that phone ring because I don't know how to pause. So we'll wait just a minute or two. Nothing like interrupting a video lecture. Okay, where were we? 10 kilograms per millimeter. What is P? So we'll put down here P, and we'll put a big question mark there. We don't know what P is. When Q equals 40 kilograms per millimeters cubed. Okay, so we're going to use these values in order to find out our constant. Then we're going to use that constant back in the equation to find P. So let's do that. 30 millimeters cubed equals K over 10 kilograms per millimeter cubed. Okay, so to get this out of the bottom, we've got 30 millimeters cubed times 10 kilograms per millimeters cubed. Our millimeters cubed cancels out, and we're going to end up with kilograms. So we should end up with K. Sorry, I needed to put that K in there, didn't I? K equals 300 kilograms. Let's see, I've made a little mistake here. This was millimeters squared. So if this is squared, we cannot cancel that. We'll end up still with 1 millimeter. So this will be K equals 300 kilogram millimeters. Alright, now let's solve for our new equation. P equals, and we've got our constant, K is 300 kilograms millimeters. over 40 Q, 40 kilograms per millimeter squared. P will then equal 7.5 millimeters cubed. Okay. So you see how we took the original equation, we put in values to find our constant, and then we have relative information, okay, something very similar that we can use the same constant, 300, in order to get the new P. And what was that P? Did it tell us what that P stood for? No, it didn't. Okay, let's try one of the word problems in physics. That's what we really want to get to, don't we? Okay. This is number 22. And it's a problem in physics. Let's read it. Use exercise 6. And the fact that a given light source produces an illumination of 600 lux. Well, first of all, let's take a look at number 6. The intensity of illumination E produced by a source light varies inversely as the square of the distance. So let's get that equation from number 6. E, which stands for the intensity of illumination, is produced by a source of light that varies inversely, varies inversely as the square of the distance. So that would be d squared. So there's our equation from problem 6. Now let's apply that to this new exercise, number 22. Let's see. A given light source produces an illumination of 600 lux, or lumens per meter squared. So we have 600, and I'm going to put this as lumens per meter squared, because you're going to see how the units cancel out. On a surface 2 meters away, that's our distance, right? So 600 is E times d squared equals K. So here's E, that's our illumination, and we have D as 2 meters squared. So that equals K. So after you do this multiplication, 4 times 600, you should end up with 2400. And again, see, I put it as lumens per meter squared to show you that the meter squared drops out, and we end up with 2400 lumens equals K. Now, there was more to the problem. Let's see, wasn't there? Oh, there it is. Determine how much illumination the same light source produces on a surface 6 meters away. So we want to find out the illumination. That was E. Okay. Probably would be best if we wrote down what each letter stood for. Then we won't get stuck with the wording. And we have K, which is 2400 lumens. That looks pretty terrible. Okay, and now we're 6 meters away. And that has to be squared, d squared. So we have 2400 lumens. I see my handwriting isn't any better on this than it is in real life. And then we end up with 36 meters squared. So that should give us, after you do the math, should give us 66.67, and that would be lumens per meter squared, or they referred to that as lux, didn't they? Okay, that concludes this video. I hope you've enjoyed it, and we'll talk soon.